Okay, so today we're going to look at doing or learning the knowledge or gaining the knowledge of factorial notation. We'll be successful if we can describe and define what is meant by a factorial, calculate a variety of factorials, write out and comprehend factorial notation, including 0 factorial, and locate the factorial button on the calculator and use factorial calculations to identify possible outcomes. Okay, so imagine that we have 6 cards, A, B, C, D, E, and F, and we want to find out how many possible outcomes with replacement. So if we place the cards back, so if I could have A, B, C, D, E, and F in a row, if I keep placing them back, the possibilities will be 6 times 1, 2, 3, 4, 5, 6. So 6 to the power of 6. So there's 6 possible letters for the first outcome, 6 possible letters for the second outcome. So we have 1, 2, 3, 4, 5, 6. Yep, so this could be A, B, C, D, E, F. This could also be A, B, C, D, E, F. This could also be A, B, C, D, E, F. So there's 6 possible outcomes per card, which means there is 6 to the power of 6. So there are currently 6 to the power of 6. There will be 46,656 possible arrangements. Okay. What happens if we don't replace it without replacement? So the possible outcomes would have, let's just say, would have A, B, C, D, E, and F. Well, if I wasn't to replace any of them, then there would be technically 6 possible outcomes for this one. Then there would be 5 possible outcomes for this one. There obviously here would be 4. This one there would be 3. And now I only have 2 letters left. And now I only have 1 letter left. Yeah. So that obviously, if that was an A, then I couldn't have A again. So it reduces by 1. So as you can see, this is 6 times 5 times 4 times 3 times 2 times 1. Well, that can be easily written as 6 factorial. Yeah. So if I was to use a calculator, I went 6 times 5 times 4 times 3 times 2 times 1, I'll get the answer 720 possible options. But, as I said, if I go from a number and I go multiply every consecutive number until we get to 1, well, we can write that as the number factorial. And I can type into my calculator going by pressing the number and then this button here, exclamation or factorial. You notice I get 720. So this button on the Casio is X factorial, and it's just located just underneath the on button. Okay, so the factorial notation. This is the number of ways of selecting n objects with no replacement, and that will become n factorial. Yeah. So n factorial is we start with the number n, then n minus 1, n minus 2, n minus 3 until we get to 3, 2, 1. Yeah. If I have 0 factorial, if you plug that into your calculator, you would get 1. Okay, and that's a mathematical situation. So if I have no items, there's only one way to arrange no items. Yeah. Okay, so let's use a calculator to calculate 4 factorial. Well, that's the same as 4 times 3 times 2 times 1. But we don't need that. We just press 4, right? 4 factorial, and we get 24 solutions. Yeah. 7 factorial is 5,040 possible outcomes. C is 1 over 10 factorial. Now, if you were to do that, you would come to a math error, because we don't really know. If we start with 1 times 10, we're not really sure what is the next consecutive number less than 0.1. Yeah, that's the same as 0.1. What's the less consecutive number? So you'll get a math error in this situation. Yeah, because we don't know what's the next number we would go to get to 321. Yeah. But if you had 1 over 10 factorial, well, that means the denominator is what is being consecutively reduced all the way to 1 over 1, right? So in the calculator, you will type it as 1 over 10 factorial. And we would get to 1 over 3628800. Yep. We can also write that as a decimal. 0.2. 567. And obviously we can write it in scientific notation as well. So 2.76 times 10 to the power of 1, 2, 3, 4, 7. Negative 7. Okay. Let's look at this one. We've got 12 factorial over 3 factorial 7 factorial. So if you to plug that in the calculator, you would also come up to a math error. Yep. Oh, sorry, syntax error. Because we don't really understand, the calculator doesn't really understand what we mean by this, right? Algebraically, what we understand it to be is it's 12 factorial divided by 3 factorial times 7 factorial, which is the same as kind of like, which is, if I was to write out, so 12, 11, 10, all the way to 321, all over the factorial of 3 times 2 times 1, multiplied by 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and so you would type it into your calculator with making sure that you have the multiplication symbol there. Or you could do it as 3 factorial by 7 factorial. One, 5, 8, 4, 0. So 12 factorial over. Yeah. Okay. So here we've got 4 factorial, 3 factorial, all over 7 factorial, 8 factorial. As I said, we're going to multiply them. So plug that into your calculator, you get 4 factorial times 3 factorial over 7 factorial times 8 factorial. And we get 1 over 1,041. Okay. Okay, so that is how to calculate factorials using your calculator. Alright, so let's look at some possible examples. We have 7 people that go to the movies and they want to sit in the same row. So how many ways could they possibly sit? So there's obviously 7 possibilities in the first seat, and once they've sat down, then we only have 6 more people left. And if once those two people sat down, we only have another 5, and so forth. So technically we have 7 factorial. So there's 5,040 possible arrangements of these people sitting in a row. Okay. If there were 3 boys and 4 girls, how many ways could the boys sit together in a row? Well, that would be 3 factorial. And so that's 6 possibilities. And the girl, how many ways could the girls sit in a row? Well, that's 4 factorial. And that's 24. Okay. This question says, why is 7 factorial larger than the 3 factorial and the 4 factorial? Yeah, because 6 times 24 is 144, yeah. Well, so why are there more possibilities for the group sitting in a row than there are the product of the boys sitting in a row and the girls sitting in a row? Well, in this situation, gender doesn't matter. It doesn't matter if the boys are sitting together and then the girls, or it could be mixed. Yeah. So in part A, gender is not important. Yeah. But in part in B and C, we have the gender, and they must sit together in a row. So we have boys and then girls, or girls and then boys, is important. Okay. Some more examples. We have a group of 8 actors. They're in a play. How many ways are there to distribute the 8 parts? So obviously we don't care about any particular genders in this situation. They're just 8 roles, 8 actors. So in this situation it would be 8 factorial. So 40,000, 20 different ways. Part B says, if 2 people must be cast in certain roles, how many ways are there to be cast the show? So there are currently 8 actors. Alright. This has to be, there are 2 people, they must be cast in certain roles. So let's say these are the roles that have to be cast in a certain way. Well, in this situation, there'll be 2 possibilities for that role and 1 possibility for that role. But then there's 1, 2, 3, 4, 5, 6 different roles. Yeah, so this would be 6 factorial. And here, as you can see, it's 2 times 1. This is 2 factorial. So the solution to this would be 2 factorial times 6 factorial. So, and that's 1,440 ways. Okay. All right. Now, there are 17 runners in a marathon. How many ways are there from first to last? So this is, there are 17 people that come first, that possibility is to be first, and there's 16 in the second place, 15 in the third place, and so forth. So this would be 17 factorial. And so we'll write that as scientific. So 3.56 times 10 to the power 14, in scientific notation. So John won the race. Okay, so that we're making sure that there's one particular person comes in first. So there must be 16 other possibilities. Yep. How many possibilities to list the ways? Okay, so that we've got, in this point, we've got 1 times 16 factorial. And in this way, so we've got 2.09 times 10 to the power of 13. Because we've specified that someone has to come first. That person comes first. Part C says, in another race of 17 runners, Mary and Joseph came second and third. Okay, so how many ways to arrange runners? So we've got so first place, second and third, and then all the rest of them, right? Well, so this is obviously Mary and Joseph, so there's technically, and it doesn't say they came respectively, or so Joseph could have came first or Mary, so there's technically two possibilities here, so it's 2 times 1 or 2 factorial. Okay. So we know that what place they've got. So technically, we know what 2 runners have come in. So we really have 15 other runners. Well, there's 15 possibilities for first place, because we know that they've got second and third. And so then we have 14 factorial for all the other positions. So this would be 15 times 2 factorial times 14 factorial. So 15 positions for first place. Then I have a combination 2 times 1, or 2 factorial for second and third, because we don't know which order they came in. And then I have 14 factorial for all the other players. So we have 2.62 times 10 to the power of 12. Okay. So, looking back at our success criteria, so we want to be able to describe and define what is meant by a factorial. So factorial is when we multiply a number, a large number, all the way, and every consecutive number until we get to 1. Calculate variety factorials, which we have done in these examples. Comprehend factorial notation. So we've spoken about things such as 4 factorial 3. Locate where the factorial button on the calculator is. It's just here. Yep, just above your on button. And use factorial calculations to identify possible outcomes, which we have shown through the examples. Okay, thank you very much.